We do have Chris.
It's going to be a stinker if it's Chris.
Yeah. Thank you for that, Nick. This is Chris Brown from Arm and Cambridge. So several of the user presentations earlier on have metrics on their slides, and they didn't really expand on that. I have this sort of theory of the metrics gap. So when I'm asked by management what the verification status is, what they really want to know is how many production stop bugs are there left, how many critical bugs are there left, that kind of stuff. And I answer back with, well, we've done a gazillion simulation cycles, I've proved this many assertions, I've got this much functional coverage. And there's a huge gap between the question that I'm actually being asked and the answer that I'm actually giving. I was wondering if you guys have got anything to help close that gap?
Not that's going to be immediately available, no. I think it's earlier on I asked a question about coverage, whether coverage was going to tell me I've got all my bugs out. I mean, it's used as a proxy, right? So the question is, what's the quality of that coverage? Do you know that? So I think heuristics and past data will actually start to bring benefits in that, and there's a big data question there. Can I use coverage data from my last year, 2 years, and actually use that to start to predict project schedules? That may be an avenue to explore, but I don't know of anyone yet that's got a solution in that space.
I think that one thing that I don't know how to, bridge the gap that you're talking about, but one thing that I've realized is that System Verilog cover groups and coverage is pretty much running its course, right? It's no longer flexible enough to handle the amounts of data that we want. If you run a full regression and then you suddenly have another question in mind, you cannot answer it because the coverage has already been coded up front, and it was designed to answer a specific question that you didn't think that is not relevant anymore. So I think that we need to come up with better ways for coverage. One of them could be generic databases that you query. But this is the direction that we need to go. We need to say bye-bye to System Verilog coverage. So, yeah. It will also make our life more generic in terms of recruiting people, because we don't need to, teach them something specific. Maybe we could do something more generic. So, just a point for thought.
Maybe, I guess you need to use the latest coverage techniques. I mean, that is out of question. But I'm sort of with you that you need some more data, right? You need churn data, for example, better data mining in terms of coverage. Look at the history of coverage, and then you can predict better where you're at in your verification process. Just with a single snapshot of a coverage database, that's really hard. I agree.
So I think you're going back to the coverage, and I think there's still a huge gap between coverage and how many bugs there are left. So yes, we can continue to improve our coverage understanding and how we extract data from it, but there's still a massive gap between there and where we really want to be.
I mean, to some degree, mutation analysis helps you a little bit. I know there's some big debate here in this corner, but if you can at least prove that you can find a certain amount of bugs, then you can conclude that there are probably not many left. So and historically we also measured the back rate for a very good reason, right? If you start to not finding any more bugs, you are not confident that there is no bug any left, but there are probably just a few bugs left. And mutation analysis helps you a little bit here, because you're having real kind of type bugs inserted into your system, and if you find them all, you have a very good verification environment.
Yeah, I just want to say that I think that coverage has nothing to do with bugs. The idea to have coverage, if we go through the history, we started by having directed tests, that were saying like, let's do A, B, and expect that the output will be C. And then the chip came, and we saw that when we did B and then A, there was a bug. And you go to the design engineers, and he told you, yeah, this is why we have a verification engineer. And the verification engineer said, yeah, but this is a test. You've been there. You didn't tell me to test B and then A. So then we realized we cannot count directed tests because we cannot think of all the scenarios. So then we started with constraint random. And the next problem was that, I don't know, chips came, and then, I don't know, the marketing guy say, hey, where's the USB? And we said, there was no requirement to have a USB. And he said, yes, of course we had, but yeah, it's not written, it's not documented. And then we created functional coverage. This is actually for verification engineers to make sure that all the chip aspects are covered. Okay, all the functionality is covered. It's nothing to do with bugs. So if your chip is a calculator, so you will make sure that, I know, division and multiplication, everything will work. But that's it. I mean, and you will not find a coverage point unless somebody really knows the design that makes sure that when this specific FIFO is full and you inject A and then C, then the data will not be corrupted. Because the problem is that you cannot think of all the cases. So it's like we have the same problem, but we just move the problem from the tests to coverage. But coverage is something that, people are thinking of, and you cannot think of all the cases. So coverage is not enough. I mean, the only way to make sure that you have no bugs is still, the old school, have lots of brainstorming, bringing up the marketing guy, the architect, the design engineers, sit around the table and discuss all the aspects, everything that can get wrong, because otherwise you will not be able to cover everything. I don't know what the design did. The architect don't know the little details, not even to say the marketing guy. So it's a new, I don't know, something has to change, but it does not come from the tools.
Alex, Doug, did you want to add, or should we go to the next question? Okay, should we go to the next question? I'm not sure you got an answer, Chris. I think the metrics are a proxy, but not a very good one. I think would be my summary.
Yeah, so I'm just going to echo what Chris was asking. 2 quick points. Good to know, honest admission today, that coverage is something we have been chasing for the wrong reason. And it's not related to bug quality, at least you've admitted it. So far I haven't heard this. From one spin, you seem to have a strong view on some kinds of coverage being able to get indications on bug quality. So clearly there are different challenges and interpretations. One thing I think that could help us in the short term, collectively from a user point of view at least, is thinking more in terms of requirements and specifications, and perhaps doing a good enough review at different stages of the project would help us identify what we really care about. We don't ship coverage to the customers, we ship chips that they expect to work. We don't ship specifications either, the detailed ones at least, but we might be asked to ship. And the thing is, to do a good enough job and gain enough confidence that there aren't any bugs, what you said, something needs to change, I think, is something quite simple, I think. Think in terms of requirements, think in terms of more reviews. And yes, all of the coverage that we collect needs to be collected for the right reasons. But I have examples that I could discuss on another day. No amount of coverage in any EDA tool can find these bugs. I have examples of designs. But it's okay. We know that it is not a holy grail, but it is ongoing work, and we could find. So that was more of a remark.
I think just to address what you said there, that I agree with you. The problem is, if you look at it, let's take an example, PCI Express. If you ever had the misfortune of trying to look at the spec for that, the requirements, it's a human process, and that's where the problem lies. So whilst I agree with you, I don't see that as representative of EDA, we're going to come up with an answer that goes down the requirements route, right?
I wasn't expecting EDA to come up with an answer.
I think coming at it the other way, turning the problem on its head, may be useful, but right now I don't know who's investing in big data, machine learning to try and predict patterns of behavior, and even then, the whole point about bugs is we never thought of that, right? As in, So why would you look there? If you knew there was a bug there, you'd look there, right? So we don't know what you don't know. It's one of those problems that's very difficult to there's no guarantee, as far as I can see. I'm not sure we'll ever guarantee. The software guys have faced this problem, but they're more loose about it because they kind of go, "We'll ship a patch." But in mission critical software, they've never addressed and fixed that problem in the same way.
I mean, I get involved with safety critical, and Aldec does that for avionics, often FPGA devices. Recently, I've been having discussions with the nuclear industry as well. Actually, that's quite interesting. But one key thing about safety critical, where obviously bugs can cause harm, they often follow a requirement-driven sort of verification process, and basically everything is driven from the requirements all the way down and all the way back up. But obviously, they tend to be simpler designs compared to sort of things that imagination are putting together. So, yeah, I mean, it's certainly an approach, and it's used requirement-driven. It's used in safety critical a lot, and it's a sort of cornerstone of things like DO254.
Anyone else?
Maybe one last word to the coverage. I agree fully with you with the requirement, tracing, etc., deriving your test plan it well out, do code reviews, nothing against that. But one word for coverage is, I mean, in the room, how many people have looked at code coverage and identified weaknesses in their test page? So this is a very positive thing of coverage, that we have that structural coverage analysis. So I don't believe that there is any replacement right now for this. It should be done. To which extent you do, this is a return on investment question at the end. And also the question of what's your target application? Are you in a car or are you in a consumer product?
Okay, there is a lot of research that suggests that code reviews and requirements reviews give us the biggest return on investment in bug finding, but we don't do them because people don't enjoy them. I don't think. I find it much more fun writing the system Verilog test bench rather than the code review.
Well, Mike, fortunately, they do it in avionics.
Yeah, they do. They do it in avionics, but yeah. Sorry, one more question.
Simon Watson from PhysicsNetics. This whole the topic of this conference is about verification futures, and do you guys have an opinion on whether you see a future where these tools become a lot more compatible with each other? Obviously, you're all in competition with each other, but I mean, I have in my experience, it's hard to get someone to move from one version of the same product to a new version because they're worried about incompatibilities being introduced between the tools. Not even moving between vendors because all the overhead of having to migrate from one sort of platform to another. I just wondered if you guys see any future where that becomes a lot easier for us as users of your products.
Where we're all one company, you mean?
No, I mean, I just mean within the bounds of what is possible.
Sorry, that's facetious, but you're right, there's a challenge because we're in competition. There are standards where, let's take an example that's close to everyone's heart here, System Verilog. Is it possible to port System Verilog across all the simulators today without any pain? No, right? Because it's an enormous language, right? An enormous language which hasn't, in that sense, it hasn't helped the industry. I don't think it was one of these throw every language into a pot standards. So while standards can be good, System Verilog in that sense hasn't been a good thing. I think it's great from a recruitment or whatever, as we heard before. I'm not sure there is a future in that sense. I think, as you saw from my presentation, the tools are becoming ever more intertwined and interdependent, and we're not the only company doing that, and that makes that concept less and less likely, I would suggest. But that's my opinion.
Same here.
We're the smaller of the EDA companies, and we'll work with any of the big three. if they will work with us, but yeah.
Remember, MathWorks are also an EDA company now. Just to get the plug-in for that.
So I think what maybe you need to worry about is really, that the information that is extracted out of test benches is read by everybody. I mean, you have to put your expectations low and then maybe you'll get them, right? So if you are able to, extract that information from all these platforms that we all have now, right? Emulation and simulation and format, and you can bring them up into a format that one analysis tool can read. Then you have the flexibility, because that's where the differentiation will end up, right, in the analysis. It will not be in the engines. The engines, we all have the same slide. I think we copied them from one.
There is the UCIS has been the move to be able to share coverage information. Not every EDA company is taking it up, but it's a move in the right direction. And there are some standardization going on. I think you mentioned Cadence and Mentor on this. I think it's called graph-based. Maybe it's not. Maybe that's
it's a very unsnappy acronym.
Yeah. Anyone else? No, I think we're going to go to our last question then.
We've heard a lot today about how you can use emulation and FPGAs to increase the number of cycles you can do. Are we going to see any work or any announcements about tools that are going to improve verification efficiency, kind of getting more out of each cycle?
So you're kind of there. You're hitting on coverage per cycle. Maybe is a metric that you might be interested in, right? At the moment, you'd have to create that metric with the tools. It's possible to do it and measure it, but it's not something that's out of the box. So no, there's nothing today that's going to be out of the box. I think it's something people very much care about because you invest in hardware. It's a huge investment. You want it available 24/7, and you want to be able to turn around all the jobs you want. So it's not just about megahertz and number of gates. It's about the importance of being able to have it available. Particularly a lot of big companies here will be cross-geo. So, you get projects that start in the Far East in the morning, and then the guys in Europe and the US start using the box later in the day. So in that sense, utilization of the box, which is a similar thing to verification effectiveness. But in terms of coverage per cycle, right now there's no metrics to measure that. We did, when I was in Vericity, we did look at that in terms of how we get coverage per cycle, because there's an argument that the speed of the simulator is actually relevant if your test bench is of higher quality, because you run less simulations. We never got to the point where we had a metric that we could share, as in that it was built in.
There's one other, the other side of the medal is actually the content. Right? Are your vectors good? And I believe there's a lot of room for improvement here. I mean, the constrained random approach, clearly it's its limits, and from my perspective, I hope that it's actually the portable stimulus group will help there to define a good standard to get to better content. So basically not too random anymore, more directed.
Phil, I just wanted to make sure I understood your question. What you're talking about is how effective the cycles you put in, making each one count as much as possible.
Yeah, exactly. So constraint random speed adjusting the AP versus VA issue, but you're not necessarily going to be exercising design in a better way by running 10 million cycles as thousands to make it the most out of those methods.
Sure. I mean, there are ways of not necessarily doing it on a cycle-by-cycle basis, but grading your vectors that you have in terms of coverage, which we already understand is a mechanism, probably the best we've got right now of judging. And you can do it not just on the basis of how many tests you have, but how much time it takes for them to run. And more of a cost grading. So that's possible. But I think what you're talking about probably goes a bit beyond that still.
Well, so there's some talk a few years ago from Quest Ultra, I think it was, which was some kind of way of trying to tune the stimulus to close coverage better. That we don't really seem to be hearing much about that kind of technique from Synopsys or Cadence now.
Yeah, we did look at technology and trying to automate coverage closure. It's a very tough problem. So yeah, we have a tool that will rank your tests. So you run them and then you decide which ones are the best ones to put in your regression. So in that sense, you're tuning your regression. But as I said, I think you're thinking something maybe more sophisticated than just that. Right?
Yeah, that's more the technique you're describing is more the kind of doing it afterwards.
Yeah.
Rather than something that's going to actually do it for you on the fly.
So I think that everybody shares the understanding that the need is there, right? The need to make more, to make your cycles more effective is there. Maybe not by coverage per cycle, but improving your stimuli, as you mentioned. That's the way to do it. So we all understand that also constrained random in a way it's not applicable to a large SOC or not really doing its job anymore, and we need to do this. And that's why we have this group together with Cadence around portable stimuli. That's what we're looking for.
Yep.
Maybe last but not least, there's also formal, since I'm once an employee.
You just remembered.
So there's an alternative to simulation-based verification, right? But I guess we all agree that it is always a mixture, right? You have to know where to apply what, and you can save cycles with form. That's true.
So I think it's probably best to cut now because we're 10 past 5 and we said we'd try and finish at 5. So apologies for anyone else wanting a question. So it just remains to say a few thank yous. Thank you first of all to Synopsys, so our platinum sponsors today, our gold sponsors Aldec, Cadence, Mental Graphics, OneSpin and Vtor, and our silver sponsors who are Doulos, First EDA and Massworks. Thank you all for coming as well and coming with questions. I hope you enjoyed